Okay. So I wanted to take a running start at it. A mid-latitude cyclone. Did we do the slide?
I think we did this one too.
Did we do this slide? Okay. Thank you. So we already did that one, right? That's what we left on. Okay, thanks. Keeping me honest. Keeping it 100. Okay. So, well, this works out good. So a mid-latitude cyclone, of course, we talked about anti-cyclones are H and cyclones are L. So mid-latitude cyclone, not so surprising, has a big old fat L in it. And that central low pressure then actually starts out as kind of a mustache. We have a cold front and a warm front. And as it matures, we have an occluded front by the central low. Okay? So this is kind of before the occluded front has formed. Now, we talked this week about cold fronts. Cold fronts are just crazy because cold air is more dense. And so a cold air mass who is pushing that cold front through is basically scraping the ground. And it's taking the warm air in front of it and going up and over. So that's why I kind of wanted to look at the fronts today, just a little bit ago, to see if that was kind of the situation we had coming up kind of with our thunderstorms that we're supposed to get. Because I looked at, for Burlington area, and it was like, for this evening, beginning, oh my gosh, like 11 p.m., which when the dog, I'm supposed to be sleeping, the dog is supposed to be sleeping, they won't be. But we're supposed to get some evening activity, I think. I think there was like a better than 50% chance.
Is there a chance the sun could break out today? Or?
It might be a little, we might see the sun, I don't know.
Yeah, at 7 p.m. and 8 p.m. and it just gets worse.
Okay.
It's like 70% chance at 1 a.m.
Yeah, okay, good, yeah.
Yeah, this
Not
one
good, but-
says possible impacts, wind, hail, and a low tornado risk.
Oh, I'm washing my car.
Well,
today.
thank you for that, Natalie. So,
What's convergence and divergence again?
well, we're coming up on that,
Oh, so we
convergence and
haven't
divergence,
talked
right,
about it.
yeah.
That's why it's been-
So, yeah, you kind of see, and there's different weather maps. This one actually is called a mixed weather map because we see kind of the current temperature, dew point temperatures as these station models. And then we also see these colors, of course, you recognize it as precipitation. The green is lighter or heavier precipitation, and the heaviest precipitation is orange. So, there we go, mid-latitude cyclone. And here's another image of a mid-latitude cyclone. Notice we have a little bit of an occluded front there from our central low. And we said that actually that occluded front will grow or get elongated, and it kind of, that's the beginning of the end for this mid-latitude cyclone. And I said that what I like your author does is a lot of things about this textbook, but notice that we've got G through F and G through F up here. G through F kind of skirts and pushes through that occluded front right there. And so actually you can kind of see the warm air lifted up because the cold air outran it. And then E through A corresponds to this, E through A. I think that is so cool because what your author does is he starts in this cold sector, he goes into the warm sector, and he gets into this cool sector here. So that's kind of cold, warm, and cool. I just think that's pretty neat how he does that. And we talked about overrunning, and so the warm air is what does the overrunning. So this warm air here, this maritime tropical air, goes up and over kind of the cooler air in front of it, and it creates these kind of series of flat clouds. So this, I guess I should emphasize. On this slide now we introduce the idea of the punctuation mark, the comma. And to me, the comma is, almost looks like a tooth because, I don't know, it's almost like a comma with two tails.
No,
But
it's like a hurricane.
it does look a little bit like a hurricane. But the head of the comma is that central low. Mm-hmm. And then we kind of have the legs or a leg coming down as the cold or warm fronts.
So what are the black lines? The little dots? What are those?
The black dots, those are little station model places, and the thing that they're showing here is wind speed and wind direction. So remember, the more the flags, then the stronger the wind. And the tail is showing the direction that the wind is, I think, coming from. So speaking of hurricanes are famous for having these kind of satellite images, and we look at, when we talk about hurricanes coming up, we're going to talk about the clouds that are characteristic of what's going on with the ocean and the water. But these clouds give us our comma. We can definitely see the comma here. Let's see. So there's the head. So we would have a low pressure here, a central low pressure, and then we have a cold front here. I know it should be blue, but just pretend it's blue. So we have the cold front kind of creating that tail. And we do kind of have the second tail coming out here. Over here, this would be our warm, from our warm front, overrunning.
You said it's warm?
The second tail is from the warm front, yeah. But the first tail, the major tail, is from the cold front. Okay. So yeah, now we're kind of switching gears a little bit, talked about a mid-latitude cyclone. This is something I think we've talked about earlier in a chapter, or maybe even two, chapter 6 and 7. This idea of a cyclone. Do I do an L or an H for cyclone? It is an L. I do an L for cyclone. I do an H for an anti-cyclone. I usually say anti-cyclone first. That threw you off. So cyclones are lows, anti-cyclones are highs. And we talked about kind of an assortment of things that come along with those. Now, usually when I'm talking about high and low pressures like this, I'm talking about central high and low pressures on the Earth's surface. Okay? So this simply says that if you were to look at, do you guys remember this? These are Rossby waves. So wind at upper elevations, I'll go ahead and say it's from a west to an east. That's geostrophic wind, by the way. If that line is my jet stream, it kind of outlines the way the rest of the air is running. And we have these ridges. I love ruffles. I do. Ridges and troughs. Okay, and associated with ridges, we have our high pressures. Associated with troughs, we have our low pressures. Okay, so that's kind of what we have going on there. This alternating pattern of anti-cyclone, cyclone, anti-cyclone, cyclone, it works best if you have Rossby waves, because remember we talked about meridional flow, where basically it's the jet streams are flat. So there we go. So you hopefully kind of see this two dimensions. You know, here we have the Earth's surface. Okay, and here we have aloft, flow aloft. This kind of ribbon of air could be our jet stream, specifically the polar jet stream. That's between what, the ferrule and the polar cells.
Thank you.
You're welcome. And so we talked about highs associated with ridges, lows associated with troughs. So now we're going to kind of revisit this idea of what's going on at the Earth's surface with regard to cyclones and anti-cyclones versus what's going on at upper elevations. All right. So I don't know if you want to go. I think I have one more figure coming up that kind of looks at the two. Oops, go back. We said in order for your high pressure to stay a high at the surface, the problem with the high is that basically you have, I'll use the word diverging, because actually I think you need to use that word on your homework coming up that's going to be due when you come to take your test on Friday. But we said, I'll do it this way. We'll get our two dimensions here. Here I'll make an anticyclone, and here I'll make a cyclone. And so here I better go like this and like this. Okay, this is at the surface. Okay, highs we said basically you're going to have air leaving a high. So if it's leaving, then basically your high is going to dwindle down to a low. So in order to sustain a high, I said the other day, so this is what we say, let's see, this is diverging. Do you buy this? This is diverging, going away. So diverging at the surface. in order for that high to stay a high, it has to be replenished by literally air. And it's replenished by air that comes from aloft. So if you look at the previous figure, you saw an arrow going like this. So I can't do that. You have an arrow going down. So that would be descending air replenishes the air at a high. So descending air from aloft. Now, in order for it to descend from aloft, it basically needs to kink up here. Okay, and that actually comes to what this is. We need to have kind of convergence aloft to send that tube of air down. So it converges, squeezes here, it goes down here and replenishes. So it converges aloft. Now if I go over here, let's say a low, okay, what we know, and again, this goes back to what creates wind, what creates moving air in the first place. It's air going from a high to a low. So if you just let this build up, then your low is going to be converted into a high. And you don't want that. So in order for it to sustain, to be a cyclone, you have to get rid of that. In order to get rid of it, it's going to have, that air is going to ascend. Okay? And in order for it to ascend, I think of it as a little vacuum. You basically have to have a little vacuum here aloft. Okay? So how do you create a vacuum? You create a vacuum by divergence at upper elevations. Okay, so divergence up here creates an upward movement, okay, to sustain this. So how do you get divergence or convergence aloft? It can actually be kind of a kink in your jet stream, in your Rossby wave. Okay, that's directional divergence, or it can be speeding up or slowing down. So we kind of have a mixture of things being thought of in this whole kind of complicated cyclone at the surface. So here's your other picture. Okay, so this is another picture kind of showing you kind of at the surface and at upper elevations. So you see the purple line there again is your jet stream. Definitely got a Rossby wave going on. So we have a ridge and a trough. We have a high and a low pressure. Okay, and this is trying to kind of show you that you have, I called it kinking together. Okay, we have kind of kinking together here to create basically air that will go down, sustain our high, make our high happy. And we have divergence up here that basically creates that vacuum to go ahead and to make it so air will go up. So I think to me it's both speed and directional that kind of gives you, that makes it's something that we learned before. So like something we learned before, a ridge is associated with a surface high. Why? Well, this is why. Okay. A trough is associated with a surface low. Why? This is why. Okay. So mid-latitude cyclones, a big old L, right? Because they kind of skirt their way across North America. And I'm gonna, the way I told you they were born was that the Norwegian model of the polar front, I said that they were kind of born with a stationary front between the ferrule and the polar cell, and that kind of stationary front kind of evolved into a wave, and okay, but they aren't always born that way. There's a conveyor belt model that I'm going to talk about just briefly. So this is actually where our mid-latitude cyclone is born, and you're like, dude, the Gulf of Mexico, you certainly know that that can't be from that stationary front between the ferrule and the polar cell. So that has to be the conveyor belt model. But these are where they're born. This actually I think is kind of fun. You may have heard some of these terms before. The nor'easter is the name of a type of storm, and it's a mid-latitude cyclone. It's just a low pressure that develops and what we've been talking about, and it kind of takes this track and goes up like that. Alberta clippers, I've heard of those. Alberta clipper. Okay. So these are just specific names for mid-latitude cyclones. When we talk about hurricanes, I'm going to actually use the word extratropical cyclone, which I don't know if you remember in this mess of slides, but mid-latitude cyclones, another name for them is an extratropical cyclone. So that's where they're born, that's where they go. So one of the ways that meteorologists have a lot of tools at hand to try to predict the weather correctly, and one of them is kind of what are these fast winds doing at upper elevations, and they're actually, I think it's neat, they steer the storms. So I think that makes sense. So this is that other model of, instead of the Norwegian polar front model, this is the other model of how you get the conditions that will result in a mid-latitude cyclone. And it's called the conveyor belt model. And I like the figures on the next slide, but basically you have these three air masses kind of listed at the bottom. And remember that warm, moist air will be the most buoyant, will want to rise. Cold, dry air will be your most dense. And so we kind of have this sort of multiple movement of air. So here is your conveyor belt model. Okay, and you can kind of see in the bottom there at the Earth's surface, we have our cold front, and we have our warm front. That's kind of the mustache I talk about. You just have air everywhere. Dry air going down, warm, moist air going up, and here we have cold air also going up. But in this situation, you still get the characteristic cloud cover that we talked about, kind of that comma shape. All right. Now we kind of switch gears a little bit and kind of talk about a little bit something I feel like we've talked about before. It's possible that we said that kind of when I drew the jet stream with the wiggles, okay, the jet stream with the Rossby waves, that's kind of a nice health alternating high, low. It's possible that your flow aloft does not allow for kind of that movement of major weather patterns. And so it's possible that you have basically something can stay. It's called a blocking high. So here's a blocking high. Looks like it's just hogging up the entire North America there. Now with high pressures, we generally think of warm, dry conditions, but this blocking high, actually historically, it brought down a continental Arctic air mass, okay? And so it basically blossomed, and there's no jet stream to kind of move it along its way. Here we have a blocking high, okay? You'd be like, well, I thought high pressures were warm and dry, and you're right. Low pressures, though, if you figure you have a blocking high, it can actually be in the way of somebody who's got a low sitting on it. And this is what happened actually during our 2 flood events. Instead of the weather kind of moving on so we get something new, okay, it just stayed where it was, did not move. So instead of getting the dry conditions that were just to the west of us, we were stuck with precip.
20 inches of rain in 2 weeks for the orange.
Not good. So aside from a blocking high, I kind of feel like we might have talked about this a little bit. To me, this pink line up here, which is your jet stream, to me, this kind of looks like zonal flow. It has a little bit of wave to it, but it's pretty flat. Okay, and so with zonal flow, remember, you don't have your alternating cyclone, anti-cyclone, cyclone, anti-cyclone. So this is actually a cutoff low that can spin for days. And one of the things that I'm hoping you get out of this chapter is lows are cyclones, and there are generally some things that come with cyclones, including usually rain. Okay, highs are anti-cyclones. They're usually dry. Okay. So I think we just barely have enough to knock out a review session.